Everyone. So here I am explaining the max flow graph. Um, okay, so first we using Ford Fulkerson method. So first we are this is the given graph. In the given graph, we are finding the augment path to reach destination T from source. So we can say like from here, the first path I am finding is from source to T is this kind of path. So after finding the first path, we are highlighting that, and then we are in the right side we are maintaining the flow network. Before maintaining the flow network, we should know what is the minimum capacity in this flow. So in this flow 16, 12, 9, 14, 4 is the minimum flow. So from every edge we are going to minus the 4 by 4 value. So here we are just representing 4 by 16. Out of 16, 4 is used. 4 out of 12, 4 is used. 4 by 9, 4 by 14, 4 by 4. Right side we maintain. So first step is we find augment path, we found minimum CF, and then in the right side we are writing in terms of this one. So in the second diagram, for the previous path, what we need to do, we need to minus the 4 in that previous path. So the values for the previous path is 12, 8. So first step we need to flow minus minimum CF of previous step. That one we need to do, and then we need to draw the residual network, the red color one. So the previous flow is this one. So for that flow I have draw the 4 4 4 4 residual network in the red color. Residual is nothing but um, uh, it's like how much we used. Here already 4 was there, 4 we used. So residual is actually remaining capacity. That means here we had 12, we used 4, so we have 10 in the actual path. Likewise. So after doing this, again here in this graph, we'll be having left graph now. This we are going to do augment path, finding the augment path, which is highlighted in green. We see this as the augment path. Here actually it became 0, no, to reach the, so we can't use any path which is going from before T hereafter. So we'll be using this edge. This we have 20. So here in this path we see we have 12, 10, 10, 7, 20. So 7 is the minimum capacity. So here in the right side, previously we had 4 here now, so we were writing like 4 by 16. Now the minimum path is 7, so 4 plus 7, 11 by 16 we need to write. Likewise for the all the edges of the current path. So current path, and this one is not used in current path. Previous value is 4 by 12 in the above graph, so we are maintaining the same. Then in the again further step, we need to minus the 7 from the this path. So 12 minus 7, 5. So likewise, before going to find another augment path, we are actually minusing the previous minimum path, and we are forming the actual value, and then the residual red color path also we are maintaining. So sometimes we may need to use residual flow also to reach the, we need to use this red color flow also. That's why we are maintaining this one. Okay. So left side, we are finding the new path, and then we are minusing the CF, and then we are maintaining the residual. Right side, we are just writing out of the actual flow how much flow we have used. So here after 7, 5, that previous path is used, and then now we are finding one more new path, which is here 1, 2, 3, 4, this one. So in this path we have 13, 11. This one, no, it's actually a residual path. Initially it had 4, but after we use this path, it is updated to 11. It was like 10, 7, no, so 4 plus 7, 11. So now that's why we are maintaining the residual flow with actual uh, uh, capacity. Now we found this path. So here we are right in this path, the minimum capacity is 3, 11, 8, 10, 20, 13. We already used 7, so remaining is 13. So 3, if this is 8 is the minimum path. So here for this path we need to write 8 by 13, and here it is 8 by 11, here it is 8 by 8, here it is 13 minus 8 is 5 by 20. It is actually 5 by 20, not 15 by 20. Okay, so we have 5 remaining here. After this one, again we need to draw this one. Initially we need to flow minus min CF, like in this flow 13 minus 8, 5. So previous flow we need to, here we 11 minus 8, 3. So for the previous flow we need to minus the minimum value. So we'll get one graph, and then we need to draw the residual. So here we used 8, so we are representing that 8 with red colored pen. And in the right side, overall how much flow we used out of the actual flow we need to maintain. For that, in the current path we need to find. So remaining we have one, here we have 5 capacity. So we have within the 5 we can use, we are finding this path now because this is already 0, and to reach here we have 5. If we use any other, this is 0, 5. If we use 3, this is again 0, so we can't come here. So we are finding this as one path. So here 5, 4, 5 we have. So 4 is the minimum capacity. We are reducing that 4 here. So 4 means 4 will be 0, which will be updating in next graph. This one we are not maintaining all the path, like the red color all and all we are not maintaining. Here we are representing only the actual given graph, in that how much we used. That's it, flow network. So here only we'll be maintaining. So in what was the previous path and how much used. So here 5, 4, 5. So we used 4. So remaining is 1, 0, 1. So this is our actual path. Hereafter we are unable to find any other path. So we are saying to the edge we have 19 plus 4, 23 is the maximum flow given. The min cut, we were cutting from this edge, and we are saying like so we can consider source V1, V2, V4 as 1, and V3 and T as one more flow. So here 19 plus 4, 23, 12 plus 11, 23. This 12 plus 11 is 23. So maximum flow is 23, we can remember. Thank you.